morning, sunshine.
Morning.
How are you this morning?
I'm good. How are you?
Doing good.
Good.
I was like, I wonder if anybody's going to show up, because I posted the review. Oh, and there's Steven. Hey. I was just curious if anybody was really going to show up for the review because of the fact that I posted both it and the answer key on the Google Classroom. So
Yeah.
But I'm so glad that you did. And I remembered that you emailed me and you wanted me to do some on the back. So how about if I start in the back and work forward?
Yes, ma'am.
Stevens, that work for you okay? You good with that if I do that? Oh, and there's Eli. All right. Eli, I'm working backwards through the worksheet. I'm starting at the back and moving to the front. Let's see. Where did you want me to start? It was 18? I don't remember now.
30.
30. Okay. I can't remember. Sorry.
You're good.
Okay. I'm just going to review the instructions for set 4. You're supposed to find the GCF first, and then then you would factor whatever is remaining. And what's going to be remaining is going to be one of two things: the difference of squares or a regular trinomial that we've been factoring. The difference of squares, you'll kind of know those right away because they're going to be the ones that have 2 terms in them. So that's going to be 23, 24, 25, 26. That's going to be your difference of squares. The trinomials are going to be the ones that have 3 terms, because you can kind of figure that out. Tri meaning 3, like tricycle. So the first thing that you're going to want to do on all of these is look for a common factor that is the same in each of the 3, or in the case of difference of squares, 2 terms. So the thing that's going to be common in number 30 is there's a number in common and a letter. The letter that's in common in all 3 of them is the Y, because there's a Y in each of them. And if we remember back to our class notes when we first started doing common factors, is that when you find a common factor, you want to take the smallest of the exponents. And the smallest of the exponents in this case is going to be 1. The understood 1. And then the greatest common numerical factor is going to be 4 in each of them, because 4 goes into 4, 4 goes into 4, and 4 goes into 120. So if I factor out a 4y out of each of the 3 terms, I'm going to be left 4 divided by 4 is 1. And then y cubed divided by y, when you have a variables divided by variables, you just subtract the exponents. So 3 minus 1 is 2. So that's going to leave me a y squared. And then 4 divided by 4, once again, is 1. And then y squared this time divided by y. 2 minus 1 is y. And then now we're going to divide 4y into 120, negative 120, and that's going to leave me just 30, because y divided by y is just 1. So now I've got a regular trinomial, and I wouldn't necessarily have to have written these ones, there. I was just doing it to show you, but that's not going to, this should look now familiar to you guys, in the fact that this is just a regular trinomial that we've been factoring, where you try to find 2 factors of 30 that when you combine them, add to be 1 or positive 1. And to get a negative, you have to have 1 positive term and 1 negative term. So factors of 30, 30 and 1, 15 and 2, 6 and 5. And remember, this drives what the bigger one is supposed to be. This tells me I have one negative and one positive term, and this tells me what the bigger one will be. Because when you have a positive and a negative and you combine them, you find the difference and give the sign of the higher one. So positive 6, negative 5 would give me a 1y. So y plus 6, y minus 5. Does that make sense? Does that help? All right. I'm hoping so. Any questions? Can I make it clearer? Any questions about it? All right, number 29. I'm going to look and see what's in common for all three. And that's going to be the letter X. There's no numbers in common because there's not anything other than 1 that will go into 1, 9, and negative 52. The only thing that's in common is the X. So if I take an X out of each term, basically I'm taking an X cubed and dividing it by an X. So then I subtract the exponents. That's 3 minus 1. So that's going to leave me an X squared. And now I'm going to take an X out of 9X squared. Subtract those exponents. I'll have a 9X. And now I'm going to take an X out of negative 52X. So that's going to leave me just a negative 52. So the next thing I'm going to do is look for two factors of negative 52 that when I combine them, give me a positive 9. This tells me that this number or this sign here tells me that I'm going to have one positive term and one negative term. And this term tells me that the bigger of the two is going to be positive, because when you have a positive number and a negative number, you find the difference and give the sign of the higher one. So let's think of the factors of negative 52, making the bigger one negative. That's going to be negative 52 and 1, negative 26 and 2, negative 13 and 4. And I think that we found the winner. Actually, it should have been positive 52 and positive 26. Then I flipped it. But I do think I found the winner, because if you take a positive 13 and a negative 4 and you combine them, that's going to give you a positive 9. So the factors for this are positive 13 and negative 4. Number 28. I'm looking at this, and the only thing I can take out of all three terms is the number 2. So I'm going to divide each one by 2. If I take a 2m squared and take a 2 out, it's going to leave me m squared. If I divide negative 4m by 2, I'm going to be left with negative 2m. If I divide 2 by 2, I'm left with 1, because 2 times 1 is 2. So now I've got a positive 1. So I'm looking for the factors of a positive 1 that when I combine them, give me a negative 2. Well, I know in order to multiply something to get a positive, I have to multiply either 2 positives or 2 negatives. So I know the only factors of 1 are 1 and 1. So in order to get a negative, these would both have to be negative. A negative 1 times a negative 1 is a positive 1. A negative 1 times a negative 1 plus a negative 1 is negative 2. So m minus 1, m minus 1. This also could be written as 2 times m minus 1 squared because you've got 2 of them, if you wanted to. But I'm reminding you of that because if you ever see on a test m minus 1 squared, you need to know that that's a binomial when you write it out. So you would have to FOIL it. All these good new terms that we've learned in this chapter. All right. So for number 27, I can factor out of 3 out of all 3 terms. Yeah. Remember, the divisibility rule for 3 is to look at the digits and add them together and see if they add up to be something divisible by 3. And 7 and 2 add up to be 9. Love you. Be careful. 7 and 2 add up to be 9, and 3 is divisible by 9. Or 9 is divisible by 3. There we go. So I'm going to take a 3 out. And if I take a 3 out of 3x squared, or divide 3x squared by 3, I'm going to be left with an x squared. If I divide a 15x by 3, I'm left with 5x. And if I divide a negative 72 by 3, I'm left with 24. And now I have a regular trinomial to factor. So I'm looking for the factors of negative 24 that when I add them together will give me 5. So in order for it to be negative, I'll have to have one positive term and one negative term. And the bigger of the two needs to be positive because the sign before the middle term is positive. So I'm going to have positive 24, negative 1, positive 12, negative 2, positive 8, negative 3. And I think that's my winner. But the other one is positive 6 and negative 4. Which the top one gives me a positive 23. This one gives me a positive 10. This one gives me a positive 5. This one gives me a positive 2. So I'm looking for the positive 5. Oops. Need to write this in factored form. Positive 8, x minus 3. Is this making more sense to you guys?
Yes, ma'am.
Yes.
Good. Just remember, you're looking for factors of that last term, that final term, and you're adding to get the middle. So factor to get the C, combine to get the B. All right. Now we're going to be looking for common factors for number 26. And we know with the 2 terms, what we've learned so far, once we factor everything out, we're going to be left with the difference of squares. So if here I can factor out a 6 and an A. Because I see a 6 in both terms and I see an A in both terms. You want to look for letters and numbers that could come out of each term. So if I take a 6A out of 6A cubed, I'm going to end with an A squared. Because if you have an A cubed, just kind of reminding you once again, if you have an A cubed and you take an A out, 3 minus 1 is 2. That's how you get that good old quotient rule from exponent rules. And then if you take a 6A out of 24A b squared, you're going to end with a 4b squared. And now I should be left with a difference of two perfect squares. A squared is a perfect square, and 4b squared is a perfect square. So don't forget to write your 6a. And this is the difference of two squares. So the square root of a squared is a, plus the square root of 4b squared is 2b. And so then you just write that same thing again with a minus sign in the middle, because it's the difference of two squares. So you take the square root of each of the terms and separate them by a plus in one set of parentheses and a minus in the other. All right, number 25. Nothing but letters here. I know how much y'all love that. So what you're doing is, what do both of them, what is the smallest thing that both of them have in common? And each of them have an M in them, but this one over here is a 1. So you have to take the smallest, and both of them have N's in them. And this is the smallest. So if I take an mn out of m cubed n, I'm going to have an m squared left. And if I take an mn out of m n cubed, I'm going to have an n squared left. So now m squared minus n squared is the difference of two perfect squares. So I'm going to take the square root of each. So the square root of m squared is m, plus the square root of n squared is n. And then I'll do the same thing, but this time I'm going to separate it by a minus sign. That way it gives me the factored version of m squared minus n squared. That's the factors of the difference of two perfect squares. All right, number 24. What I see in this one is that I could take a 5 out of each of the two factors. So, and nothing else. There's no letters in common. I know y'all are relieved by that. If I take a 5 out of 45x squared, I'm going to be left with 9x squared, minus 5 divided by 5 is 1. And that crazy 1 is a perfect square. That's one of the ones that typically throws people off, but 1 is a perfect square because 1 times 1 is 1. So now 9x squared minus 1 is a perfect square. So don't forget to write your 5, but now you're going to take the square root of the first term, which the square root of 9x squared is 3x. And the square root of 1 is 1. So I'll write 3x plus 1 in one of my parentheses and 3x minus 1 in my other set of parentheses, because that's how you factor the difference of two squares. All right, number 23. Something that will go into 75 and 48. And remember, your number 1, 2 is that we want to check with your primes, and 2 is the first greatest common factor that you can think of that's prime. But numbers have to be even in order for 2 to go into both, and 75 is not even. So the next prime number we come to is 3. And the divisibility test for 3 is to add both digits and see if they're divisible by 3. 7 plus 5 is 12, and 12 is divisible by 3. 4 plus 8 is 12, and it is divisible by 3. So 3 goes into 25 or into 75 25 times. The other thing you're kind of looking for, since you have two terms, you're kind of looking for perfect squares. And 25 is also a perfect square. And 3 goes into 48 16 times. And yay, 16 is also a perfect square. Because when you have a binomial and a subtraction sign in the middle, you're going to hope, oh, it's going to be easier and easier to factor because this is going to be the difference of two squares. So when you're looking for divisibility tests, you kind of want to test things to see if it's a perfect square also. And both of these, 25r squared minus 16, that is both of those, the 25r squared and the 16 are both perfect squares. So the square root of 25r squared is 5r, and the square root of 16 is 4. So in one set of parentheses, you'll have 5r plus 4. The other set of parentheses, you're going to have 5r minus 4. And how that happens, remember, if you're to check this and FOIL it out, that middle term cancels out. So those are the greatest common factor first. Any questions on 23 through 30? I'm hoping this review is really helping you guys. Number 22. I'm looking for two factors that when multiplied give me a negative 30, that when I combine them or add them, I get a negative 27. So knowing that this sign is negative, that tells me, oh, one of my factors is going to be negative. One of my factors is going to be positive, because a positive times a negative makes a negative. And in order for this sign to be negative, the bigger one is going to have to be negative, because when you combine a positive and a negative, you find the difference and give the sign of the higher one. So factors of 90. 90 and 1 with the big 90, that would give me a negative 89. Negative 45 and 2, that would give me a negative 43. Negative 30 and 3, oh, that gives me a negative 27. So there you go. So x minus 30, x plus 3. Number 21, I'm looking for factors that give me a negative 30, that when I combine them, give me a positive 13. The negative here tells me that one is going to be positive, one is going to be negative. The positive here tells me that the bigger one is going to be positive. So factors of 30. 30 and negative 1. 15 and negative 2. Oh, and I think that's it, because 15 minus 2 is 13. So I have my factors. A plus 15, A minus 2. Number 20. I'm looking for factors that give me a positive 64, but a negative 16. To get a positive, you either have to multiply two negatives or two positives together. So this tells me I'm going to be multiplying two negatives together. So I'm looking for factors of 64 that when I combine them would give me a negative 16. And
Can you scroll down a little bit, please?
What do you mean?
I can't really see number 22.
I'm sorry. Like this?
Yes, ma'am. Thank you.
Okay, yeah. For so I'm looking for two factors of 64 that multiply together or that add together to give me a negative 16. So negative 64 and negative 1 would give me a negative 65. Negative 32, negative 2 would give me a negative 34. Negative 16, negative 4 would give me a negative 20. Negative 8 and negative 8. And there it is, right there. W minus 8, W minus 8. And once again, this, because there's two of them, can also be written W minus 8 squared. And I continue to show you that because I want you guys, a lot of you on the quizzes, when you would see W minus 8 or something else squared, you're just squaring the first term and the last term. That doesn't work. You have to write it as a binomial and FOIL it because it comes up as a trinomial. Number 19, looking for two factors that multiply together to give me a negative 45 that when I combine them, give me a negative 12. Well, the negative here tells me one's going to be positive and one's going to be negative. And the negative here tells me that the bigger one is going to be negative. So negative 45 and 1, that's negative 44. Negative 15 and 3. There we have it. Because negative 15 plus a positive 3 gives me a negative 12. So my answer is X, or no, it's C. C minus 15, C plus 3. Number 18, looking for two factors of negative 36 that when I combine them or add them, give me a positive 9. The negative on the 36 tells me one is going to be positive, one is going to be negative. The plus sign on the 9 tells me the bigger one is going to be positive. Because when you combine a positive and a negative, you find the difference and give the sign of the higher one. So factors of negative 36. Negative 36 and 1. Negative 18 and 2. Negative 9 and 4. I missed one. Negative 12 and 3. And there it is. Oh, actually, I flipped it. This should have been positive all along. And these should have been negative. A positive 12 and a negative 3. So you can always adjust your factors because sometimes you might flip them as well. You just want to double check your final answer to make sure your bigger one does match the sign that precedes that middle term. And a positive 12 and a negative 3 is a positive 9. Any questions so far? Everybody caught up to me?
Yes, ma'am.
Okay. Number 17. Positive 16 and a negative 10. Well, it takes two negatives to make a positive and to combine them and get a negative. So I know both of these factors of 16 are going to be negative. So I'm looking for two factors of 16 that are both negative that combine to be a negative 10. Negative 16, negative 1, negative 8, negative 2. And there it is, because 8 and 2 equal 10. So y minus 8, y minus 2. Number 16. I'm looking for two factors that multiply together to give me a negative 38 that combine to give me a negative 17. The negative on the 38 tells me one's going to be negative, one's going to be positive, and the negative on the 17 tells me that the bigger one is going to be negative. So negative 38 and 1, that doesn't work. Negative 19 and 2. That does work because a negative 19 plus 2 gives me a negative 17. Number 15. Looking for two factors of 6 that multiply, obviously to give me 6, that when I combine them, give me a 7. The factors of 6 are 6 and 1, and there she is, and 3 and 2. So it's x plus 6, x plus 1. Any questions on the back side? Are y'all feeling more confident in these? Is everybody feeling like they're going to be able to do this on their own tomorrow?
Yes, ma'am.
Okay. Good deal. Okay. Factor the difference of squares. All right. Starting with 14, keeping with the theme of going backwards, I'm looking for a perfect square of 196. And if you have to, since you know with the directions, it says the difference of squares. You can always use your calculator to find the square root of something. But I do suggest memorizing them if at all possible, through 25, just so that and some of them are a little harder, like in your teens and that kind of thing. So just, I don't know, challenge yourself to memorize a new one each day or something like that. 196, the square root of 196 is 14. But, obviously you can always plug this in your calculator. And you've got a perfect square in the a squared, so that's going to be a. Basically on these, you're just taking the square root of the first term and the square root of the second term. So the square root of the first one and the square root of the second one, and you're just writing them out. Is that making sense to you guys? And then separating them, you're making two sets of parentheses, taking the square root of the first term, square root of the second term, and then separating each of them by a plus in one set of parentheses and a subtraction sign in the other. So on 13, the square root of c squared is c. The square root of 81d squared is 9d. So your first set of parentheses looks like that. Oops. And your second set should be a subtraction sign. And number 12, be real careful when you have a four like that. The square root of w to the fourth is w squared because you're basically cutting it in half. So be careful on something like that. Okay? Don't let the fact that that's a 4 throw you off, or a 6 or anything like that. You're just going to cut it in half. And then the square root of -10, make sure you're doing the square root and not cutting a number in half. So that's not 50, it's 10. You only cut, in order to find a square root of an exponent, you cut the exponent in half. But numbers, the square root is whatever a number times itself. So don't get the two confused. The square root of 16x squared is 4x. The square root of 49y squared is 7y. So you just repeat that same thing once you get the square root and put a minus sign there. The square root of 1 is 1. The square root of 25n squared is 5n. This one, don't get tripped up by that because it's a plus sign there. It's prime. It's not the difference of two squares. Hold on just 1 second, guys. I have a wee bit of an emergency. I apologize. I apologize for that. Number 8, the square root of y squared minus 289. Or the square root of y squared and the square root of 289 is going to be y plus 17, y minus 17. And number 7, the square root of a squared and the square root of 64. A plus 8, a minus 8. All right, factoring the polynomials by determining a greatest common factor. So with number 6, you want to look for not only numbers that will go into each one, but you want to look for letters that are in common. And if there's a letter or a variable that's in common with each individual one, then you will look for the highest or the smallest exponent of that letter. Okay, so they all have an M in common. What is the smallest exponent on the M's? Anybody tell me on number 6?
M squared.
Good job. It's M squared. So when you see a letter or a variable that's in common in each of the factors, you find the one with the smallest exponent. And in number 6, that's M squared. The number that's in common with each one is a lot of times I look for the smallest number or coefficient on each of the 3. And in this case, that's a 6. But 6 won't go into 21 or 15. So I'm going to go a little smaller. 3 will go into both 6, or will go into 6, and it will also go into 21 and 15. So I believe that I can take a 3 out of each of these. So 3 divided by 21 divided by 3 is 7. And then M to the 5th, you always want this to be smaller underneath here. What would that leave me? M what? Five minus 2.
3.
3. Good job. And we're not taking an n out, so I have to write that n squared because it's not being divided. Okay, 6 divided by 3 is 2. And then I've got m cubed divided by m squared. What would that be?
Just M.
Just m. And then n. And then plus 15 divided by 3.
5.
Good job. 5. And m squared divided by m squared is 1. So that doesn't change the 5 because if I multiply the 5 by a 1, I still get 5. Okay. On number 5, 1 is the only thing that will go into all 3 coefficients, 10, 9, and a 1. So there's no greatest common factor of a number. But do all of them have letters or variables in common? And if so, what are they?
They all have A and B in common.
They all have A and B in common. Good job. They all have A and B. And the smallest of the A's is just an A, right? Because there's an A squared in the first term, but there's only an A in the second term. There's an A squared in that third term, but you have to take the smallest exponent. So we're going to stick with A. And the smallest exponent on the B is also just a B by itself. There's a B squared in the first term, and there's a B squared in the second term, but that third term only has a B. So our greatest common factor for number 5 is AB. So if I take an AB out of 10A squared B squared, what would I have left?
Just A and B.
Yep, just a A, B, but I also write my 10. But good job. Yes, just A, B. Good job. So if I take an AB out of 9AB squared, what am I going to have left?
9B.
9B. Good job. And if you need to write it like that just so that it's easier for you to see, please, please do. What will I have left there?
A.
A. Good job. That's it. So that's number 5. Any questions about number 5? All right, number 4. Once again, I kind of check the biggest number that will go into both of, I check the biggest number, the coefficient, and see if 8, like, well, 8 will go into both numbers, but 8 won't go into 22. So then I go down to 4. 4 won't go into both of them. It doesn't go into 22, but 2 goes into both of them. So I know 2 is the number, but do they have any variables in common?
X and Y.
X and Y. Good job. What is the largest X that they have in common? Or the smallest X they have in common? I'm very sorry.
X3.
X to the third. What is the smallest Y?
Y to the fourth.
Y to the fourth. So you take the smallest exponent on the variables that they have in common. The smallest exponent. And that was in your notes when we were doing greatest common factor. So if you need to kind of go back and review some of those problems, that's a good thing to do, or rework these until you really start to see it. All right. So if I take 8 divided by 2 is what?
4.
4. Good job. Do I have anything else left? If I here, wouldn't this cancel? So there's just a 4 for that first term, right? Does that make sense to everybody when I write it out? Does that make more sense to you guys when you see it that way?
Yes, ma'am.
Okay. All right. So now let's take a look at this second term. $22 divided by 2. $22 divided by 2.
11.
11. And then x to the 5th divided by x to the 3rd. 5 minus 3. Anybody there?
2.
Okay. Good job. And then 6 minus 4.
2.
2. Thank you very much. I'm trying to make sure you guys get this because yesterday it seemed like the last of the worksheet, like the first 6 and the last 4 were the ones that people struggled with the most. So I'm trying to get you all to kind of talk through it with me to help you for the quiz tomorrow. All right. And good old number 3. There's nothing that will go into both 5 and 12, and they don't have matching letters. So number 3 is prime.
Okay, that was the one I was confused on.
Yeah, no, nothing will go into both 5 and 12 evenly, and they
Is
don't
it
have
always
matching letters.
prime? Is it
I'm
always
sorry.
prime when there's an addition?
It's not always prime just because there's an addition sign, but that's really, really smart that you observed that. Other things make it prime as well. When there's nothing that will go into all of the factors, like a 2, a 3, a 4, or 5, won't go into all of the factors, and there's no matching variables. That's something. And then if there's 2, like down here, we were looking at difference of squares, but there was a plus sign here in the middle. And so that made that prime. If this would have been m squared minus 81, it wouldn't have been. Or even if there would have been an m here on that, you could have at least factored out an m squared. Does that make, or an m? Oops, my bad.
Yeah, that makes sense.
Okay. So when there's no matching letters and no prime numbers that will go into all of the terms, then it's prime. All right, number 2. What are there any matching letters, and what number will go into both of the terms?
2 and C.
2 and C. Good job. There's a C in all of the terms, and 2 will go into both 14 and 2. So 14 divided by 2 is
7.
7. And then if you have C squared divided by C, what do you get?
C.
Good job. And then 2C divided by 2C gives you
C.
2C.
Oh, 0. 1.
1. Anything over itself is 1. 4 over 4, anything like that. So 2C divided by 2C is 1. Good job. All right. What number will go into both 21 and 15?
3.
Good job. 3. 3 goes into 21x. What do you have left?
7.
7x. Good job. And then 15y divided by 3 is
5.
good job. 5y. All right. Well, that's the whole worksheet. I hope this review really helped you guys. If there was any that you really struggled with, my suggestion is you pick a couple from every section and try a couple hours from now after the review. Just try every now and then, just maybe do one throughout the day while you're doing your other homework or whatever, just to make sure you're honed up on your skills for the quiz tomorrow. And email me if you have any questions.
Thank you so much for giving us this review sheet. It really helped me.
Oh, good. I'm so glad. No problem. And I posted it and the answer key, so y'all can work it as many times as you want. That's on Google Classroom. Plus, I'll repost the math lab. And email me if you have any questions.
Thank you.
Y'all have a blessed day. Thanks for coming to Math Lab.